In this type of ensemble, we have a system which can exchange its energy with the surrounding. This we will see in further diagram. Consider a canonical ensemble describes a system in thermal contact with heat reservoir at a fixed temperature. In this example, the system can exchange energy with the reservoir while the total number of particle and volume remain the constant. So in canonical ensemble, we have two conditions: volume and number of particles would remain same, and temperature could be exhaust, means this can be transferred to the surrounding or a environment. In simple example, if we see a gas confined to a container with a movable piston and in thermal contact with a heat reservoir at a fixed temperature, the gas particle can exchange energy with the reservoir, but the total number of particles and the volume of the container remains unchanged. So here you can see the box or a system. At fixed temperature, particles can exchange their energy to the surrounding but have constant number of volume and number of particles. These two conditions are necessary for canonical ensemble. So in simple term, in canonical ensemble, N means number of particle, V means volume, and T means temperature. So this shows that N remain constant. It means walls are impermeable. This means that wall does not exert force on a particle. V means constant volume. It means walls are rigid. And third is temperature constant. It means walls are diathermal or thermally conducting valve. This shows that particles can exchange their energy, their temperature can be changed with respect to their surrounding. So the system will be closed system. Here you can see that three particles, their energy, or you can see at heat reservoir, this shows that heat is releasing downward. This means that the surrounding temperature impact on the particle in a closed container or a closed system. So here you can see microcally and here you can see macrocally. So we have three conditions, and number of particles, volume and temperature. These three terms would be same in canonical ensemble. After reading about the canonical ensemble, there is a question which arises that why is it called canonical ensemble? So if we see that if the temperature of a system remains same, this means that system is isolated, not interacting with other system, then the system will be microcanonical ensemble. And if the interaction will be occur, this means that particle temperature with respect to their surrounding changes, then the system will only known as canonical ensemble, not micro. So this is the basic reason we called it canonical ensemble. So the next question is why we need canonical ensemble. So the answer is canonical ensemble is used for calculating overall statistical and thermodynamic behavior of a system without explicit reference to the detailed behavior of particle. So in simple term, canonical ensemble is only calculating tool for statistical and thermodynamic behavior. So this is very important to study. Next we see about the reason why we prefer canonical ensemble. So as already we see that in microcanonical ensemble we have a number of particle, volume and energy is constant because system is isolated. And in canonical ensemble we have a number of particle, volume and temperature which is constant, but we have only closed system. So already we have seen this in detail. So since in microcanonical ensemble energy is constant for each system, in canonical ensemble particle very easy to maintain temperature as constant, because for that we have put all the system in constant with heat reservoir or infinite heat capacity, and that a easy task. And third term is maintaining temperature as constant is also very easy, because for that we have to put a thermometer in a system. So all these properties we have already studied in detail for microcanonical and canonical ensemble. So here we have isolated system in which no heat enter, no leave, energy remain constant, and here we see that and mean number of particle, volume and temperature remain same. So we have closed system, and these all properties we already have studied. If we did not see, go and see previous lecture and see in detail. There is an important question which arises if we can study any system via microscopical ensemble in which we have number of particle, volume and energy which is same, because the system is in microcanonical ensemble is isolated. So why we need canonical ensemble in which we have constant temperature? So there are two reasons. First reason is in microcanonical ensemble, maintaining energy as constant and monitoring of it is tedious work from practical perspective. That's why we are moving away from microcanonical ensemble approach, because it is very difficult to maintain the temperature energy of a particle. So isolated system is very difficult to attain because external temperature environment also affect. So in microcanonical ensemble approach, we have to find number of microstates, and sometimes for some system it's nearly impossible to find number of microstate. That's why we move away from microcanonical ensemble approach and we use only canonical ensemble.